Factoring is really the opposite action of multiplying. But whereas multiplying is pretty mechanical, factoring is actually fairly difficult and relies on patterns. So I've got a couple of little examples here. 3 times 5 equals 15. Taking the two numbers, 3 and 5, multiplying them to get 15. Going in the opposite direction, you're taking the number 15 and you want to write it as the product of two factors, 3 times 5. Now, as an example of why this is difficult, let's consider taking two 5-digit numbers. So if I gave two 5-digit numbers to the average grade 5 student, they could sit down with pencil and paper and use the algorithm they have for multiplying and get a very big number, probably about a 10-digit number. However, if I gave them the 10-digit number and told them to find the two 5-digit numbers that multiply to give them the 10-digit number, in other words, to factor that 10-digit number, that would take them a very long time, even with a calculator, because there's no special algorithm we can use to factor things. The only algorithms that would be available would take a long time. So factoring relies on patterns, and we're going to see the pattern we used to multiply binomials when we get to factoring trinomials. First, let's take a look at some simpler factoring problems, which is just identifying common factors. So a common factor essentially means you're looking at all of the terms of an algebraic expression, a polynomial, and you're trying to identify if there's any factor that's common to all of them. Now, you're already familiar with common factors from integers. It's not really that much different with algebraic expressions. You still actually need to find the common factor of the two coefficients, which is really just an integer question. So 10x, 5y, what do we have in common there? The 10 and the 5, let's focus on the coefficients first. The greatest common factor of 10 and 5 is 5. So immediately you can start by writing 5. And then the x and the y, they don't have anything in common. So 5 is the greatest common factor. Now as soon as you identify the greatest common factor, you simply write it and then put a bracket, because we're going to be turning this into a product. And then you ask yourself, 10x is that GCF 5 times what? Well, you're just doing a division in that case. You're taking 10x and dividing it by 5, and you're getting 2x. And you want to verify that 5 times 2x does indeed give you that first term, 10x, which it does. And then if we took the 5y and divided that by 5, we would have simply y. And so now we have factored this. We've turned it into a product of two factors, 5 times 2x plus y. And again, if you want to verify that you've factored it correctly, just multiply it. The multiplying should be pretty straightforward. You can do it as an area model if you like. You can take the 5 and multiply it by 2x plus y, and make sure you actually get back what you started with. 5 times 2x is 10x, 5 times y is 5y, and sure enough you have the expression that you started with. So let's do that for the next two. Focus on the coefficients first, 6 and 9. The greatest common factor of 6 and 9 is 3. Then we have x squared and xy. Alright, so x squared is really just x times x, and xy is x times y. So the only factor they have in common there is one of the x's. So x is part of the greatest common factor, and the full greatest common factor is 3x. So what do we have to multiply 3x by to get 6x squared? Well, to get 6, we have to multiply it by 2. To get x squared, we have to multiply it by x. And sure enough, you can verify quite easily that 3x times 2x is 6x squared. For the second term, what do we have to multiply 3x by to get 9xy? Well, we have to multiply it by 3, certainly, and we have to multiply it by y. And now you have it in fully factored form. And go ahead and verify by multiplying that when you multiply 3x times the binomial 2x plus 3y, you actually get the binomial that we started with. Let's do it one more time. 18 and negative 6. Don't worry so much about the negative, just focus on the 18 and the 6. So 18 and 6 have a GCF of 6. The xy and the y, greatest common factor of y. What do we multiply 6y by to get 18xy? Well, a 3 and an x. And what do we multiply 6y by to get negative 6y? Has to be a negative, and it's just negative 1. And go ahead and multiply that to verify that you get the original expression. Now, a little trickier is factoring trinomials, but it's not really that tricky if you remember the pattern that we saw in the last lesson, which is that if you think of a trinomial of this particular form as x squared plus the sum of two numbers times x plus the product of those same two numbers, then really this just becomes like a puzzle. You're trying to find two numbers with a given sum and product. So let's say for the first trinomial there, x squared plus 5x plus 6. What two numbers have a sum of 5 and a product of 6? I find it usually easier to start with the two numbers that have a given product. There's far fewer combinations. There's pretty much an infinite number of combinations that'll give you a sum of 5, but very few that'll give you a sum of 6. And if you have to, you can list it out. A product of 6 can be formed a few different ways. 1 times 6, 2 times 3, and there's actually two other ways, negative 1 times negative 6, and negative 2 times negative 3. Those are the four possibilities. And what's the sum in each of these cases? Well, 7, 5, negative 7, and negative 5. So clearly, the one we're looking for is that second row. And the two binomials are therefore x plus 2 and x plus 3. That gives us the right sum and the right product. Now, this little table on the right is quite interesting because what it shows us is if we have a product of 6 that we're looking for, there are really very few sums that are going to work. Just 7, 5, negative 7, and negative 5. So if you saw a trinomial, for instance, that was x squared plus some other number, let's say 8, x squared plus 8x plus 6, there's no way you can factor that because you can't find two numbers that have a product of 6 and a sum of 8. They don't exist, and therefore you can't factor it at all. Let's try this for the next one. Two numbers with a product of 10, sum of 7. Go ahead and list all the pairs that give you a product of 10 if need be. X plus 2 and x plus 5 work because 2 times 5 is 10 and 2 plus 5 is 7. Now, once we get into negatives, if the product is positive, but the sum we're looking for is negative, that means we're looking for two negative numbers. So, again, I don't really worry too much about the negatives at first. I put them in afterwards. We're looking for two numbers with a product of 12, sum of negative 8. 6 and 2 have a product of 12, but they have to be negative 6 and negative 2 to give us the right sum. So it's x minus 6 and x minus 2. The order of the factors doesn't matter because remember, it doesn't matter the order in which you multiply things. Okay, again, we have a positive product. We have a negative sum. So both of them are going to be negative. Product of 16, sum of negative 8. The only way that's going to happen is if they're both negative 4. So x minus 4 and x minus 4. Okay, now we have negative products. That means one of the numbers is going to be negative. One of the numbers is going to be positive. So for negative 15, there's only a couple of pairs that are going to work here. 1 and 15, with one being negative, the other positive. Or 3 and 5, with one being negative, the other positive. Obviously, it's 3 and 5, but here you've got to be really careful to get the negative on the right one. It's a sum of negative 2, so it has to be x minus 5 and x plus 3. If you put the negative on the 3 and the positive on the 5, the sum will be positive 2, not negative 2. There's a unique way to factor these sorts of trinomials. You should not have two possible answers. So again, here we have a negative product. One's going to be negative, one's going to be positive. This time the sum is positive though. So go through the list, 128, 214, 7 and 4. It's obviously 7 and 4, and get the signs right. So it's x plus 7 and x minus 4. That gives you the right product, negative 28, and the right sum, positive 3. This gets a lot easier with practice.